All right, if you would turn to page 121 in your lab manual, I would like to go through a few examples that we have listed in there. Let's start with problem number 1. In problem number 1, we have x plus 1 times 2x minus 3 times x minus 4, and that is greater than 0. So here we have a factored polynomial, so we need to locate our zeros, and so our zeros and our multiplicity. So we have x equal to -1, multiplicity is 1. We have 2x minus 3 is equal to 0, so that's 2x equal to 3, or that's x equal to 3 halves, and its multiplicity is also 1. And our last one is x minus 4 equal to 0, so that's x equal to 4, again with multiplicity 1. So for each one of these, we're going to have a linear behavior that is going through each of those zeros. All right, so what do we do next? We need to graph. So our zeros are -1, 3 halves, and 4. So let's put -1 on here. We have 0, we have 1, so this would be 3 halves. This would be 2, 3, and then we have 4. Now, because our inequality is greater than 0, we want to have open circles at each of our zeros. And these are the different sections we're going to be testing. All right. So we have section A, B, C, and D. All right, we need to figure out the end behavior of our polynomial. So we want to look at the leading coefficient. Here we can see that outside we have a 1, so that's positive, and this is positive, this is positive, and this is positive. So our leading coefficient is indeed positive, so that means the right hand side is going to be trending up. The degree is going to be if we add our multiplicities together, so we have 3 in total, so our degree is 3, so that's odd, so that says that my, wrong direction, means my left hand side has to be trending in the opposite direction, so it's going to be going down. So we need to be going up something like this, and then we know this one is going to have to be trending like this, and this one's going to have to be trending down like this. So we can connect these two, so we have a polynomial that has a behavior like so. All right, so now we're looking for the sections that satisfy our inequality. So going back up to our inequality, we see that we're looking for values that are greater than 0. So which x values produce an output greater than 0? Well, that's going to be in section B and in section D. So if we focus on these two sections, what x values correspond to those sections? And we find that our solution is going to be from -1 to 3 halves, and then from 4 to infinity. So that is our answer to problem number 1. All right, let's move on. Let's look at problem number 2. So for problem number 2, we have x cubed minus x squared is greater than or equal to 0. So we're going to have to factor this one. It's not factored. So if we factor out x squared, we end up with x minus 1 is greater than or equal to 0. So we have the following zeros. We have x is equal to 0. The multiplicity here is going to be 2. And this is going to give me a 0 of 1. And its multiplicity is going to be 1. Let's look at our end behavior. My leading coefficient is indeed positive, so my right hand side is going to be up. My degree is 3, so that's odd, so it has to be trending down. So we have a 0 at 0, and I'm just going to 1, 2, 3, just to spread this out, I'm going to put multiplicity, my 0 of 1 over here to the right. We need to separate out our sections here. So we have section A, B, and C. And now we need to put our circles on. So because we have greater than or equal to 0, that means that for both of these, that means that we need to include our zeros. So those are going to be solutions. And now we need to make our sketch. Now, on the right-hand side, when we look at our 0 at 1, that multiplicity is 1, so we know that it's going to have a linear behavior going through. So it's going to do something like this. And at 0, the multiplicity is 2. Now, since I'm down below, we know that this is going to come up, it's going to hit, and it's going to bounce, and then it's going to have to trend back down. And we can see that our end behavior matches up. All right, so now let's find our sections that match our inequality. We're looking for inequality that is greater than 0 and equal to. So we're equal to 0 here, we're equal to 0 here, and we're greater than 0 here. So all of section B will satisfy along with our 2 zeros. So let's write out our final answer. So we have an answer at 0, starting at 1, going to infinity. All right. Next problem. Let's look at problem number 4. So we have 2x cubed is greater than 8x. So we need to get our right-hand side equal to 0. So we get 2x cubed minus 8x is greater than 0. So first thing we want to do is factor out our GCF. So that's 2x. So we get x squared minus 4 is greater than 0. We can continue to factor further. We get x minus 2, x plus 2 is greater than 0. So now we have our inequality fully factored. Now let's locate our zeros. All of these are going to have a multiplicity of 1. So we have an x equal to 0, multiplicity 1. We have x equal to 2, multiplicity 1, and x equal to negative 2 with a multiplicity of 1. Looking at our end behavior, looking at our leading coefficient is 2, so that means it's positive, so that means my right hand side is going to be trending up. The degree of my polynomial is 3, so that's odd, so that means my left hand side has to be trending down. All right, we'll put our zeros on. So we have negative 2, negative 1, we'll say this is 0, this is 1, and this is 2. We are looking at, so we highlight our inequality here. We see that it's greater than 0. So we need to have open circles at each of our zeros. And let's go ahead and create our different sections. So we have section A, B, C, and D. So let's create our graph. To sketch our polynomial, we know that we're going to be trending up on this side. Multiplicity is 1, so it just goes through. It's going to have to turn and go through 0, and then it's going to have to turn and go through negative 2. We're looking for where the graph is above the x-axis, so that's going to be section B here and section D here. So our final solution is going to be from negative 2 to 0 and from 2 to infinity. And I'm going to stop right here. I do have the final answer key for this polynomial inequality lab manual. I don't have them all worked out, so my challenge to you is for you to work out problem number 3, and I'd like for you to work out problem number 5, and you can check your final solution with the answer key provided on Blackboard. Any other questions you have, we can discuss when we meet together.